In this video, I'll be showing how to solve an electrical network using Thevenin's theorem. Yes, Thevenin's theorem is known to you, that is, it states that any two terminals of a network can be replaced by an equivalent voltage source and an equivalent series resistance. The voltage source is the voltage across the two terminals with load, if any, removed. Then the series resistance is the resistance of the network measured between two terminals with load removed and constant voltage source being replaced by its internal resistance or short circuit if no internal resistance given, and constant current source replaced by infinite resistance, that is open circuit. So here a network is given and it is asked to find the value of current flowing through 24 ohm resistor. So the step 1 is, so whenever you are asked to find the Thevenin equivalent circuit, if you are asked to find a current flowing through a particular resistance, then that resistance should be taken as the load resistance. So while doing the Thevenin's theorem, what you have to do is that load resistance has to be removed and keep it open there and find the Thevenin equivalent voltage. Then the second step is like you have to find the Thevenin equivalent resistance by removing the sources, looking into the circuit from that open terminals. Okay, that is Thevenin equivalent resistance. Okay, now we'll see how to solve it. So step 1 is to find VTH. So we'll find VTH is the Thevenin equivalent voltage. Now for finding VTH, we have to remove this load resistance. Load resistance is nothing but that 24 ohm given in the question. So here I'll be redrawing the diagram with that 24. This is 30 ohm. Here it is 20 ohm. This is 50. And this is 5 ohm. And here we have the battery 220 volt. 220 volt is given. Now here this terminals I'm opening it, the 24 ohm. So I just mark it as A and B plus minus VTH. The voltage across this terminal is called Thevenin equivalent voltage. Now I'll mark direction for currents also. Let me mark this current through this branch as I1, current through this branch as I2. We can see that the same current I1 is flowing through this 30 ohm and 50 ohm, and I2 is flowing through 20 and 5 ohm because these two are connected in series since this A and B terminals are open. Now we will write the equation. So now to find I1 by applying Ohm's law, we'll be getting 220 divided by the resistance across that voltage. It is 30 plus 50 since they are connected in series. So we'll be getting 2.75 amperes, and I2 is 220 divided by the resistance, that is 20 plus 5. So 20 plus 5, we'll be getting it as 8.8 amperes. Okay, now we can write the equation for VTH. So VTH equation we can write by applying KVL in that particular path. So VTH plus 30 I1. So when you mark the current, current direction, it is from there to here, so it is plus minus. Here it is, this is plus, this is minus. Suppose we are traveling in the clockwise direction and writing the equation, then we'll be getting VTH plus 30 I1, then minus 20 I2 is equal to 0. You can see here that VTH, and here minus, it is going from in the polarity of 30 ohm. When you travel in clockwise, it is minus to plus, so it is positive you have to give, and across this 20 ohm we are going from plus to minus, so minus. Now we can, from this equation we can write VTH is equal to 93.5 volt. So when you substitute the values for I1 and I2, you will be getting this value. The step 2 is to find RTH, that is Thevenin equivalent resistance. So for finding RTH, what you have to do is we have to look into the terminals from that open terminals. At the same time, you have to remove all the sources present. So here we have one voltage source. So this one is A and B. Across this plus minus we have VTH, and here this one is 30, this is 20, this is 50, and this is 5. And we are shorting the voltage. When you are removing the voltages, we have to replace it with a short circuit. Now we can just mark this I1, here it is I2. Okay, now this is A and B. Now just observe this network. We can see there is a short placed between this 30 ohm, this junction of 30 ohm and 20 ohm, and junction of 50 and 5 ohm. So I can redraw this diagram. I'll be redrawing the diagram so it will be clearly understood. Okay, I'll just this is because the terminals A and B, it is open, so we have just taken it out, just redrawn it in a different direction. Okay, this is 30, this is 50, this is 20, and this is 5. Okay, so here we can see when you are finding the Thevenin equivalent resistance, that is when you are looking into the circuit from A and B. So here you can see this 50 and 30 are in parallel. Also this 20 and 5 are in parallel, and the combination. So RTH is equal to 30 parallel 50 plus 20 parallel 5. So when you take the equivalent, when you do the calculation, you will be getting it as 22.75 ohms. Okay, so now step 3 is to calculate IL, that is the load current that is being asked in the question. So we know it is, we can redraw the diagram. So here, then this is the load resistance. Okay, here load resistance we know it is 24 ohm. Here RTH is equal to 22.75 ohms, and VTH, that is equal to 93.5 volt. Okay, this is what, and the current through this one is IL. So IL is nothing but, it is, we can find it is 93.5, that is voltage divided by the total resistance. Total resistance is 22.75 plus 24, so that is equal to 2 ampere. So this is the current flowing through 24 ohm resistor. This is how you can solve the network using Thevenin's theorem. So I'll solve one more problem here. Let me draw the diagram. This is 10 ohm, this is 40, this is 100 volt, then this is 20 ohm, this one is 30 ohm, this is again 30 ohm, here it is 40 ohm, and this one is 50 volt. The question is find the current through find the current through 10 ohm using Thevenin's theorem. Okay, so find the current through 10 ohm using Thevenin's theorem means we have to consider that 10 ohm as the load resistor. So first step is to calculate, to find VTH. So for finding VTH, we have to redraw the diagram, and we know that 10 ohm has to be open circuited, because VTH is nothing but, it is the open circuit voltage when that 10 ohm is removed. Across the terminals we'll be finding the open circuit voltage. So here we have this one, let me mark it as A and B. So across this we'll be finding VTH. This one is 40, this is 100, this is 20, this is 30, this is again 30, this is 40 and 50 volt. Okay, so now what can be done is, since it is looking like a mesh, we can just assume mesh currents. Okay, I1, then here I can make it I2. Okay, So when it is I1 like this, we can see that it is like this, the direction. Okay, now we can apply KVL because it is a mesh. So KVL to mesh 1 will give you the equation 100 minus 40 I1 minus 20 I1 minus 30 into 30 is the current is I1 and I2, the difference of I1 and I2. So we'll be getting I1 minus I2 is equal to 0. When you simplify this one, we'll be getting 90 I1 minus 30 I2 is equal to 100. So this is equation number 1. Now KVL to mesh 2 will be getting minus 30 I2, then minus 40 I2 minus 50, then minus 30 into I2 minus I1 is equal to 0. When you simplify this one, you'll be getting the equation as 100 I2 minus 30 I1 is equal to minus 50. So this is equation number 2. So you have two unknowns and two equations. So you can solve for these two equations for finding I1 and I2. I1 is equal to 1.05 amperes and I2 is equal to minus 0.185 amperes. You got these two currents. Now we can write the VTH equation by writing that loop equation. Okay, so write VTH equation. So we'll be getting minus VTH plus 30 I2. I'll just show that one. Plus 30 I2 plus 20 I1. You are traveling in the clockwise direction is equal to 0. So you'll be getting VTH is equal to 15.45 volt, because we know the values of I1 and I2. Substitute it and find the value for VTH. So the second step is to find RTH. RTH is the Thevenin equivalent resistance. So we have to, for finding Thevenin equivalent resistance, what you have to do is we have to remove the sources, and if it's a voltage source, we have to replace it with a short circuit, and if it is a current source, we have to replace it with an open circuit if there is no internal resistance present. So now here we have an voltage source, so we'll be replacing it with a short. So that one we have put, this one is 40, this is 20, this is 30, this is 30, and this one is 40. And here we know it is terminals A and B plus minus VTH. Okay, so we'll be looking into the circuit to find RTH. Sorry, this is I can't write this as VTH. It is RTH because we have shorted that voltage source. Okay, now what we can do, now here you see this portion, you can see there is a star network present here. So I can just convert the star network into a delta network. Okay, so I'm just converting star to delta. Okay, formed by 20, 30 and 30 ohms. Okay, so here R1 I can find it as 20 plus 30 plus 20 into 30 divided by 50, divided by 30 is equal to 70 ohms. R2 is equal to 20 plus 30 plus 20 into 30 divided by 30 is equal to 70 ohms. Same thing we are getting because R3 is equal to 30 plus 30 plus 30 into 30 divided by 20. So you will be getting it as 105 ohms. So the star we are going to replace it as a delta network. Okay, so how I'll just draw it here, delta network. So this one is 70 ohms, this is 70 and this is 105. Now we have that 40 ohm also connected. Let me draw like this, 40 ohm, and here it is again that 40 ohm, right, 40 ohm. This looks bit complicated, okay, but it is only the diagram is looking complicated. It's fine. So when you look into this, you will be getting RTH, okay. So this is how you are getting the circuit. The circuit is looking like now, okay. Now what I can do is I'll be simplifying this network, because I know this 40 and the 70 are in parallel and this 105 and 40 are in parallel, so I can find the equivalent resistance. So 70 will be there, we will keep like that, 70 ohm. Then those parallel resistance equivalent we can find. So 70 and 40 in parallel, you will be getting 25.45. Here 105 and 40 will be getting 28.9 ohms. Then here we have that open terminals, okay, A, B. Here you will be getting RTH inside. So now this one, you know, 25.45 and this 28.9 are in series. So I can just draw like this. I can draw the equivalent. So here this is 70 ohms and this one is 54.42 ohms, okay. So now we have the terminals A and B, okay. We'll be looking into this one to find the Thevenin equivalent resistance. So this 70 and 54.42 are in parallel, so you can, the parallel combination will be getting it as 30.62 ohms. So that is connected across this A and B. When you look, this one is RTH, okay. So here from this one we'll be getting RTH is equal to 30.62 ohms. Now when you have to draw the Thevenin equivalent, step 3 is calculation of IL. So for that we need to draw the Thevenin equivalent circuit. That is a voltage source in series with a resistance. This voltage source is nothing but Thevenin equivalent voltage and resistance is Thevenin equivalent resistance, and this is our load resistance. So here we got it as 30.62. RL equal to 10 ohm, we already know, and VTH we already found, it is 15.45 volt. So here this is IL. So will you find IL is equal to VTH upon RTH plus RL. So we know the values, so 15.45 divided by 30.62 plus 10. So this one you will be getting it as 0.38 amperes. So this is the value of current which is flowing through the load resistance 10 ohm. So this is how you will be solving electrical networks using Thevenin's theorem. So hope you understood this solution using the Thevenin's theorem. Thanks for watching.